Hello class and welcome to an intro lesson to 9.7. I wanted to do this in order to allow us to have more time to discuss harder problems. So this is just the introduction. Please take good notes and pause at any time and try examples. So I wrote down the three functions that we're going to talk about inverses for. Now inverses, going way back to last year and the beginning of this year, inverses must be one-to-one, meaning for every y value, they can have only one x value. So you can't have repeated y values. They have to pass the horizontal line test is another way to think of it. And none of these functions do, just how they sit. So what we've done in math is restrict the domain in order to allow them to have inverses. So for cosine, we restrict the domain to be between 0 and pi. So your restricted domain is now from 0 to pi. This allows us to capture all the output values from 1 to -1 for cosine. So similar things been done for sine to capture all the values and for it to pass the horizontal line test. We restricted it from -pi/2, which is right here, all the way to pi/2, which is right here. So it's been restricted down. So write the restrictions out. Okay, and last but not least, tangent. So we just took one of these slices. So the slice that falls in here is the one piece that they're going to find the inverse of. So the domain of that one is, again, the same as sine, -pi/2 to pi/2. So for inverses, the big idea here is that their x and y values are switched, they're inverted. So going on to the next page is where I'm going to explain what the graphs of the inverse functions look like. Okay, so here are your three inverse function graphs, and you can pause and just draw these things out. So I wanted to just write down their domain and their range, and these are the ones where they've switched the x and y values. So on the previous graphs, you had your x-axis look like angles and your y-axis was numbers. Well, this is reversed because they're inverses. So if you look at your graph, and you might want to pause if you want to try the domain and range yourself, the domain of this graph is -1 to 1, which was the range of sine of x. They're switched. And the range of this is the restricted domain from the previous page. So between, you can see it goes from -pi/2 to pi/2. So cosine, you got your domain. See if you can think about the domain. -1 to 1. Domain goes left and right. Range is 0 to pi, which was the restricted domain from the previous page, just they switch. And arctangent, or the inverse of tangent, you have, what do you think the domain is if you look at that? Yep, all real numbers. The range is between -pi/2 and pi/2. So now we have it all set up. So now we know what kind of answers we're going to basically get when we solve inverse functions. So that's what we're going to do next, some intro examples. Okay, so we're going to do some examples of solving. This is where I like to pull out my inverse land and think of it this way. So this is how I think of where the answers are going to fall for the inverse questions. So in quadrant 1, from 0 to pi/2, you're going to have all the trig functions, the inverses of positive numbers. This is where all the answers will fall, between 0 and pi/2. Because answers to trig functions are angles. The y value, the output, is an angle. In quadrant 2, going from 0 or pi/2 to pi, you only have cosine inverse of a negative number. If you look at the graph again of cosine inverse, you'll see why that makes sense. And nobody had any kind of values in here, any kind of domain. This is what I call no man's land in there. So the last quadrant over here, quadrant 4, is where we're going to have our sine inverse and tan inverse. And these are going to be negative angles going clockwise. As you could see, the range of sine inverse and tan inverse went to -pi/2. So this is when you have a negative number that falls in here. You're going to have angles, negative angles between 0 and negative 90. Okay, so on the side, what I'm looking for on these examples is to figure out what angle, like the first one, I'm figuring out what angle makes sine equal root 3 over 2. Sometimes I kind of draw a little picture when I'm doing these if I'm not sure. So this is a quadrant 1 angle because it's a positive number in here. And I'm going to draw a picture. I'm looking for the angle. I know sine is y over r, or opposite over hypotenuse. So I know this side's 1, and I'm dealing with the 60-degree angle, or pi over 3. Second one, this is a quadrant 2 answer. So it's somewhere between 90 and 180. So draw a little mini picture here. The angle I'm looking for is right here, but I'm going to find the reference angle first. So cosine is your x over your r, so I'm going to put negative 1 over 2 for the radius. This must be root 3. These are all the ones you can do by hand. So in here is 60. So my angle is actually 120 for this one, or 2 pi over 3. Some of these I won't have to draw pictures for. Tan inverse of a negative, we're talking about a negative angle somewhere in quadrant 4. So I'm just going to draw my little triangle. I'm thinking it's the 45-45 because that's the one I remember tangent being 1 or negative 1 for. So it's y over x, yep, and that's your root 2. So it's negative 45 degrees or negative pi over 4. So you can see how these examples continue. I think what you should do now is pause it and try to get the rest of the answers that come on the slide. They're going to come up in a second. I'm going to write them all out and bring it back up for you. And this last one down here is also pi over 2. So I wrote the 3 answers out just in radians. I hope you were able to get those. If you have no idea what's going on, we're still going to be talking about this on the Tuesday we get back from break. Okay, on to the next. Okay, this one's going to be really easy. It's all calculator examples. So what you want to do is set your calculator to radians or degrees, whichever one you want to start off with, and you're going to hit the sine inverse, the buttons that have the negative 1 with them. So they're right above your regular sine, cosine, tangent. So these are just simple practice. So what I'm going to do is have you guys try these, and then I'll have all the answers come up here. So pause it now. And there you go. There are your answers. So you can see the first one is a negative angle, and that makes sense because you have a negative value that's going in the quadrant into quadrant 4. The second one, you have a negative angle, so that should be quadrant 2, and the angle shown is definitely in quadrant 2. And example number 3, that's in quadrant 1, and 42.61 degrees is in quadrant 1. So the little inverse land helps me also check if my calculator's doing the right thing. Okay, on to our last example of the day. You've been doing great. Okay, these ones are using inverses to solve for angles, and I'm sure you've done this in not only geometry, physics, honors algebra 2, and now here again. So we're just going to kind of lightly breeze over it, and we'll wait to do some of the little bit more challenging problems on Tuesday. So what I'm looking at is I'm looking at the angle and what 2 sides I have. So can you figure out what trig function is going to work with the 2 sides that I have? So what I'm thinking is I have the adjacent side to that angle, and I have the hypotenuse. So I'm going to use cosine. So I'm going to write cosine of theta equals 4 over x. Now, the way we solve for angles is we use trig functions. So that's where I'm taking cosine inverse of each side. And what that does is cancel the cosine out on this side. So I end up with theta equals cosine inverse of the right-hand side, 4 over x. There you go. You showed it. You can't solve that one because you don't know what x is. Okay, example 2. So I'm looking at what I have, and if you want to pause and try to think about what trig function would work for this red problem. What I'm thinking is you have the opposite, you have the hypotenuse, so I'm thinking sine's the way to go. So sine of that angle equals x plus 3 over 2x. Again, take sine inverse of each side, and if I could not show that step, I should be fine. You guys should hopefully understand that to solve for the angle, you want to take the inverse. there you are. Voila. So that's it for all the examples. The next thing is going to show you what problems I want you guys to try over break. So here you go. In class, we're going to finish 9-7. So please complete the following problems. They shouldn't be too bad. This is kind of the only one that I didn't show you an exact example for, but I wanted you guys to try that. And don't forget, keep calm and enjoy your holiday. Thank you very much.